All right, ladies and gentlemen, welcome to this series. This is going to be a kind of like can I say a lecture series? Yeah, let me just say it's going to be a lecture series. It's in the form of a course, and we are going to focus. It's not really a course. It's just a short tutorial kind of series that we're going to focus on digital asset management. As you already know, digital assets are becoming uh, legitimate nowadays. We do everything digital, so why not have some digital assets in your portfolio? But then this course, we are not teaching you how to get digital assets or anything, but we want to bring you like a practical format how you can manage digital assets using machine learning, right? So that's why I named it predictive rule-based digital asset management. So for example, we know machine learning today, uh, it can pretty much, you can build a model that can predict the future. But so if you have knowledge about the future, you can use it for your advantage, right? So that's what we're going to try to do in this series, right? So we're going to do digital asset. We're going to look at digital asset management. We're going to build a predictive model, and we're going to build rule based. We are going to build rules to manage our asset based on our knowledge of the future given to us by a prediction model. So that is what we're going to do here. So this section, I'm just going to give you an overview of what we are going to do and what we want to achieve, right? So it's going to be more of like a lecture to hands-on thing. Like I'm going to give you a hypothesis or a task of what I want to do, and then I'm going to kind of like go into Python to do it. So if you have a knowledge of Python, if you've used Python before, this will come in handy. But if you haven't used Python before, I'm going to provide you some notebooks. If you can read code or you can just run and follow and try to learn, that would be great. So stay tuned and follow me if you're interested in things of this form, right? Um, so to begin, we want to establish really a hypothesis for what we are doing, right? So I will use this as a form of a research question. So if you're doing research in any institution or you're just curious about how things work, you can also ask this question and try to solve the problem. So the point is that we have a digital asset. We have a digital asset trading market today, and everybody tries to find a profitable trading solution, right? So nowadays we know that machine learning is ubiquitous, is everywhere. Like we have it, we have models out there, but can we utilize these models to have a prediction of the future and build rule-based systems that can help us capitalize on the digital asset trading? So this is I'm going to be giving you. This is going to be like kind of like a lesson, a practical aspect of doing this. It's not any kind of form of financial advice, or it's not form of like you're going to, but you can learn from this and take it to the next level, right? So I'm going to give you a foundation where you can learn to build your own models and take it to the next level. So that is what we're going to do here. And so this is our thesis, right? So this is the objective. This is what we want to achieve. We want to use machine learning to predict to be able to predict the price of an asset in the future, and we develop rule-based trading strategies, right? So this is kind of like a decision system, if you may. So the solution approach we're going to use here is the first thing we are going to do is we're going to list a number of assets that we are going to consider, right? So we can't just use all assets. Digital assets it's really a fresh market, it's very new. So we're going to list, there's a criteria that we'll choose the assets that we are going to use. And then we are going to collect the data, right? So this is the solution. We have to decide which assets are we going to consider. You can think of that yourself. And then we have to think of where do we get the data and how long can we get the data for, right? In finance applications, data is usually like really not quality data is really not available. So when we get the data, we need to pre-process the data. to be able to do our predictive machine learning. So we are going to model the problem that we are going to solve, right? So we still have to define what are we predicting, right? So we're going to do that. And then to design our model, we're going to do some feature engineering. So feature engineering here just means that we are going to craft some signals by ourselves to give the model, to help the model to be able to learn how to do better predictions. And so when we do that, we also have a way of evaluating the performance of our model. So this course, this series, is going to focus on this. So you can also take this in the form of a tutorial, right? You can take it as a form of a tutorial. You can take it a form of learning or whatever that suits you. But the main outcome of this that I want to try to provide is a way that we can answer this question, right? So, but in this series, we are not going to cover this. We're going to cover this in a future series, right? Future tutorial or stuff like that. Yeah, but for now, we're just going to focus on this solution, right? And then we are going to build a rule-based trading strategy for that. Okay. So, yeah, we consider some assets that we want to use. So my criteria for considering these assets was based on their market capitalization. So I did that. I went to CoinMarketCap. CoinMarketCap is a very popular cryptocurrency information price aggregation site, right? So if you can go to CoinMarketCap, I think, yeah, and then you can find prices or market capitalization and information about digital assets. So I took the top 50 assets with the highest market capitalizations. And so you can see here some of these assets are in red. So the ones in red are those that have data that is not up to 5 years old, which means that the historical data is not up to 5 years. So, and you can understand that these assets are pretty new, right? So it's an opportunity that we can capitalize on this new market, volatile market. We can use it for learning some practical applications, right? So that's the criteria where I used to choose this asset. So there are 50 of them as I've listed here, right? And then I put this ones, like I just wanted to add some assets in case I was unable to crawl the data for some of these assets in case they weren't available. All right then. So we need to collect data, right? So one thing about the data, when we are collecting data, we need to have a source, right? So Yahoo Finance is open source. Financial Modeling Prep is another one, IEX Cloud. So we need to find an open source framework or software that can get the data for us. So we're going to do that. And then we have to decide when we are getting the data, we want to decide the granularity, right? So how long in the past do we want to have the data so we can get on a daily, we can get the daily prices of assets. And then when we're getting the prices, we want to look at the features, right? So the features are just like we have the historic open, high, low, close, volume per day of an asset. So these are the base features that we want to have for an asset. So you know that there are there's other information about the asset, like the market capitalization, the rank, the circulating supply of that token, right? So we know that there's all of this information. But for now, we're going to focus on open, high, low, close, and volume. So these are the base features that we need for every asset, right? So, and yeah, I did some experiment and it shows that you can really get like substantially good results with just this information, right? Yeah. And then from there, we're going to do some problem modeling, right? So with problem modeling, what we're trying to do here is that we want to model our problem to be clear about what we are doing, right? So if we want to implement something, it's our thought. So we want to ask a question and answer it using our code. So we want to code the solution, right? So what we are going to do is we want to ask the question in the coming X days, 5, 10, 20 days in the future, what will be the percentage change in value of this asset, right? It could be Bitcoin, Ethereum, or Solana, or any asset, right? So we want to know if we can build a model that can predict the value or the percentage change of this asset in the coming X days, right? How then can we capitalize on this prediction, right? So I know that the models that we build, a machine learning model to predict the future, of course, it's not very accurate. So we are in an uncertain market environment. So we have to try to kind of take care of uncertainty in the market and try to capitalize based on the prediction that we have. So that's the goal. That's what we are trying to do. So we will predict the percentage change of an asset, and then we try to capitalize on that. And so when we are predicting the price of an asset into the future, you can predict for a day, for 3 days, for 5 days, for 7 days, right? But from the experiments that I have already done, predicting for a day is pretty hard. It's really hard. The model doesn't perform very well. But for 3 days, 5 days, and 7 days, the model does a pretty good job. So it's easier to predict for 3, 5 days into the future than to predict for one day, right? So from the model that I build, it doesn't mean that there are not models that perform well here. You can also build a model. So what I'm going to be giving you is a foundation to build upon, right? I'm going to be giving you hands-on tutorials on how to translate this modeling into code, and so you can build from there with your own ideas, and maybe you can even build a more accurate model, right? And then we are going to do that. We are going to use both regression and classification. So in machine learning, regression means you're predicting a real number, right? So if you're predicting the price of an asset, that's a real number, or the percentage change of an asset, that's a real number. So this is regression. So we can do regression or we can do classification. Classification in this sense, so I can say, will the market go up or down, right? That's classification. So I'm going to look at the data, and my model is going to predict if the price is going to go up or down, right? So predicting up is a positive change. It's going to change positively. That's a class, and it's going to change negatively. That's a class. Those are two classes. But we can do put these percentage changes into bins. So I can say, will the model change by 0 to 2%? Will the price of this asset change by 0 to 2%? And I predict as a one class, 2 to 5% as another class. So you can have multiple classes. So in this example, you can have 8 classes where you predict the price of an asset to fall within any of these ranges, right? All right, now, so the regression problem that we want to solve. So like I already said, regression is, right, we are predicting a real number. So for example, you are given features, open, high, low, close, and volume. We can craft other features from these features, some statistical changes or historical statistical features, and add to this. And then we want to use these features to predict the percentage change of an asset in the coming X days, right? Or we can predict the price directly, right? So it could go negative or positive. So this is what we want to do. And also we can predict the close price, the low price, or the high price, right? So we can predict the closing price of an asset, the lowest price of an asset, or the highest price of an asset in the coming X days. And so we can capitalize on that, right? So, and then we have our base features, and we can do some feature engineering, and we are going to evaluate our model using root mean squared error. So if you don't know what root mean squared error or mean squared error is, you can just go ahead and ask, if you use ChatGPT or any large language chat interface, you can just ask it to please, can you explain to me what root mean square error is with an example in machine learning, right? So you can just ask it that question, and it's going to break it down for you very easily, right? Yeah. And then for classification, what we're going to be doing is we are going to try to put this the percentage change of an asset into classes. So we can say an asset changes by 0 to 5%. We put it in class C. By 5 to 10%, we put it in class B. From 10 and above, we put in class A, and we do the same for negative changes. So what we are going to do here is that we have put into bins, into classes, if the percentage change of an asset, right? And so what we are trying to do, we are going to try to classify into the future, right? Given days into the future, we're going to try to predict what class is going to fall in. So if we say this asset is going to change by 5 to 10% in the coming 5 days, then maybe we classify as B. So we are going to do this, and then we are going to let our model try to predict this, and then we can use those to capitalize to design some rules. So this is what our classification modeling is going to do, right? So I'm just giving you an overview. So this session, I'm just giving you an overview of what we are going to see next. So in the coming series, I'm going to give you every step. I'm going to give you the data collection, and I'm going to give you the practical aspect, the tutorial, and how to implement that. So that's what we are going to do. So we're going to do this step by step, right? And so we can evaluate our model by accuracy. So the good thing with classification is that you can have an accuracy of your model. So you can see, okay, how accurate is it in predicting the class? So you can really get an accuracy, right? Precision recall, the same thing I told for root mean squared error. You can just go into ChatGPT and ask for this evaluation, like what do they mean in machine learning. But when we are going to do the practical sessions, I'm going to try to explain what this means, or what the accuracy, what the precision recall and F1 score means, right? Okay. And then out there are so many machine learning models that you can use for prediction and classification, right? There are so many machine learning models that you can use. So if you're using deep learning, right, you can use temporal fusion transformers. It already has a standard implementation in PyTorch, right? PyTorch time series. You can find it there. And there are other models that you can look into if you're interested. I highlighted this ones in red because they are those that I feel that maybe there would be those that we can try out in the future, right? And then ARIMA is a very popular time series prediction model, right? So for example, temporal fusion transformers, it can do both classification and regression. ARIMA can do a regression. I think you can find a way to change the regression model into classification, just like we saw with the beans. So, and I'm going to focus more in this series. I'm going to use gradient boosting machine. So like XGBoost, I'm going to use XGBoost for modeling, right? It does a pretty good job, but you have to carefully design the features that it's going to use. So we are going to focus on this, and if we have time in the future, maybe we can cover temporal fusion transformers and ARIMA. We can also cover that in the future. And then with data processing, I think most of the time, like the data source, you have to check your data, but the data I got is pretty okay. And then what I'm going to do is just feature engineering, right? This is what we're going to do. And then the final stage, how are we going to train our models? There are two ways that we can train our models, right? So we can have like, for example, I can have my assets, right? I can train my model on Bitcoin and Ethereum and try to use the model to predict the price of Solana, right? So it means like I can train on a different asset and try to predict. So you can understand that, okay, if this model can pick up patterns from training on a different asset and can predict, so it means that it's really getting how the digital asset market operates, right? So this is what we want to do. And this is the first approach we're going to use, right? And then, so this is why I distinguish them into multiple asset and single asset. I'll explain what that means in a couple of, and then we can also train using a cutoff time. So we can take all the 50 assets that we listed, and then we train on data between 2020 to 2022, and then we test on data between 2022 to 2023. So this is just an example of what we can do, right? So this is an approach that we use for multiple assets. We can use cutoff period, or we can use different assets to train and different to test, right? To build our model. And then the advantage of this one is that you can build a general model for all assets. So even an asset you haven't seen before, or you haven't trained on, you can use this model, right? And then a single asset. What I mean by single asset here is that, like the market behavior of Bitcoin and other assets are different, right? Bitcoin has been in the digital asset space for a very long while, and is and the volatility now it's still high, but it's not as high as other assets. So you can see some assets the price can change in a couple of days, maybe in just about a week. The price of an asset can change by 100%, right? Nowadays we can't really see that with Bitcoin. So what we want to do with this single asset is we want to train a specific model for this asset. So we want to train a model that specializes on trading Bitcoin, specializes on trading Polygon, specializes on trading Monero. So this is what we want to do, right? So this is what we want to achieve here. So we have an asset specific model for that, and here we have a general model, right? So yeah. So this is what we are going to do. So what I listed here is just an overview of the objective that we want to achieve and the approach that we want to use to achieve this objective. So in the coming days, I'm going to be releasing the series and the tutorials along with the code for you to try your hands on. So we're going to start with collecting the data, pre-processing, doing regression, and doing a classification, and then we're going to try to build our rule-based asset management strategy. So this is not financial advice, and you should take this as kind of like a learning process. If you're interested in machine learning, or you're interested in decentralized finance or digital asset management, this can be a learning ground for you. And I'm just going to provide you with a foundation, the code, and some background in machine learning and how to model this. And you can use that for whatever interest. If you're doing research, if you work for a research firm, if you want to use it to build your own model or your own bot, that is up to you. But I'm just going to give you a foundation for you to kind of like do that. So if you're interested, stay tuned. I'm going to bring you the details of all the other models, and yeah, we'll go from there. Thank you.